Assalamualaikum warahmatullahi wabarakatuh. My name is Fatina Jatul Umi binti Muhammad Yusuf. I am from DPC3B and my registration number is 33DPC20F1035 and this is my teammate.
Assalamualaikum, my name is Nur Anisandra binti Muhammad Razal and I am from DPC3B. My register number is 33DPC20F1038. So today we will present about task 4, severity of quenching. So the objective of this task is to study the hardness of medium carbon steel sample and their microstructure under the following condition, which is as received, annihilate, anneal, normalize, water quench, ice quench, oil quench. So the apparatus we use is 6 medium carbon steel sample, furnace at 910 degrees Celsius, tongs, Rockwell hardness testing equipment, beakers, oil, and ice quenching mediums, optical microscope, polishing machine with abrasive, weld grinder, abrasive paper, flat glass plate with a wooden framework, electric hot air blower, cotton nitrile reagent, which is action, Rockwell hardness testing machines. So this is all the equipment. So the descriptions. Intrinsic temperature is the temperature at which intrinsic reactions occurs in a phase diagram. Intrinsic reactions, liquid to alpha plus beta. Here, alpha and beta are phases of a binary alloy composed of A and B, whereas alpha is reached in A and B is reached in B. Quenching. In material science, quenching is the rapid cooling of a workpiece in quenching to obtain specific material properties. This is a type of heat treatment which prevents undesired low temperature process such as a piece transformations from occurring due to extreme high rates of cooling. Martensite. A hard and very brittle solid solution of carbon in iron that form the main constituent of hardened steel is called martensite. Its microstructure is usually needle-like, thus depicting its radial nature. So next is the procedure. Step 1. Obtain 6 identical samples of medium carbon steel and keep 1 sample aside as the control. So we keep the control sample. There's annealing, normalizing, water quenching, ice quenching, and oil quenching. So the next step is, for the second step is, I'll standardize all 5 samples for 30 minutes at 910 degrees Celsius. So set the furnace temperature to 910 degrees Celsius. So we set the temperature to 910 degrees Celsius. Okay. And then we put all 5 samples. I'll standardize it. So after we put it, we need to wait for 30 minutes. Okay, we turn off the machine and look at the result. So we remove the sample from the furnace and quench them in a different medium. Okay, step 3 is remove the sample from the furnace and quench them in a different medium. So first is oil medium, second is water medium, so the third one is the brine medium, the former we put it at the room temperature, and the last one we close the machines and let the last sample cool in a furnace till 400 degrees Celsius. So we take it out and put it in air room temperature. So once all samples are cooled to room temperature, each sample is polished and microstructure is observed under a microscope as shown in the subsequent steps. So why is the sample austenitized for 30 minutes? So the answer is for uniform austenitization. So step 4. Obtain a flat surface on the specimen by belt grinding. So we need to put the specimen at the belt grinding to have flat surface. So this is how it works. So the next step is support a polished paper of 1/0 fineness on a flat glass plate. Polish the specimen rubbing in forward direction only. So we need to move them in the forward direction. So note, move to the next fine paper 2/0 and 3/0. Once the stretch of the specimen are uniform, while changing from one paper to another, the specimen and your hand should be clean, free from the abrasive of the previous paper, and the specimen turn through 90 degrees so that the stretch from the previous paper are at right angle to the stretch from the next paper. So next step is step 6. Finish polishing the specimen on 4/0 abrasive paper. Wash hand and specimen. So we need to finish it at the last 4/0 paper, polish paper. So step 7, do the polishing, the disc polishing unit.
This is as you can see.
So as you guys can see, this one is aluminum solution. You need to put it on the disc polishing unit. So we need to turn it on, wait for it, and turn it off. So after fine polishing, clean off the polishing surface of the specimen with water and dry it with an electric hot air blower. So for step 8, I will continue. Fatin will continue.
For the step 8, etch the specimen with 2% lighter region by swabbing for a few seconds. Wash and dry it. For the note, nitrogen. Nitrogen is the name given to an oxidizing action solution composed of aqueous, nitric acid, and ethanol. So we open the top of water and we put the sample and we wipe the specimen and dry. For the step 9, to examine the specimen under the microscope and observe the structural features. And this is for annual specimen. As you can see, the structural features. This is in 100 zoom, and this is for 500 zoom, and this is for normalized. As you can see, the structure. And this is for ice quenched. This is for oil quenched. And the last one is water quenched. As you can see, the structure. So which medium give the most thermal quench? This is ice ring. For the step 10, after noting the microstructural features of the samples, perform the Rockwell hardness test using the cone injector for all 6 samples. So this is cone injector. This is samples, all the 6 samples, which is called control samples, annual samples, normalized samples, water quench samples, and ice quench sample, and this is for oil quench samples. And the hand wheel is turned until the specimen is in correct contact with the indenter, and the pointer of the smaller die gauge reaches the red dot, so that minor load of 10 kg is applied. Move the mouse on the wheel to adjust the specimen head. So, minor load of 10 kg is applied, and the major load is set. For the step 12, the major load is set and the motor is switched on. The hand lever is kept in load position for the 15 seconds. The reading is noted down using a scale, and this is a hand lever. Click on the hand lever at 15 seconds to unload. For the step 13, values are noted for the all 6 specimens. For the sample 1, the quench method as received is none because there is the control samples. The total load is 150 kilograms, and the scale used is C. Rockwell hardness number is 15. Okay. For the sample 2 until 6, the total load is same, but the quench method is different. For the sample 2 is annual, the sample 3 is normalized, sample 4 is ice quench, and for the 5 is oil quench, and for the 6 is water quench. The sample has same total load, which is 115 kg, and the scale used also same, which is C, and the Rockwell hardness number is different. For the sample 2 is 37, sample 3 is 41, sample 4 is 16, and for the sample 5 is 55, and for sample 6 is 51. Here is observation. Observe and relate the microstructural features and the obtained Rockwell hardness number. And this is for microstructural for annual sample. This is for normalized sample. And this is for ice quench samples, oil quench samples, and this is for water quench sample, microstructural. And the RC number for untreated, which is control sample, is 15 RC, and annual samples, which is 37 RC, normalized samples is 41 RC, water quench is 51 RC, and ice quench is 16 RC, oil quench is 55 RC. The hardness value obtained can be correlated with the microstructural observation. Higher fraction of martensite are observed in better quenching, thereby resulting in higher hardness value. That's all from us for severity of quenching lab. Thank you.